Hello students, welcome to the next lecture on differential calculus. In this video, let us analyze the concept of radius of curvature of a curve. To begin with, let us first understand what is curvature. While traveling, most of you might have observed the safety sign indicating a sharp bend or a hairpin bend ahead, suggesting to slow down the speed of the vehicle, isn't it? And if I am not wrong, at a turning point, the road level is slightly raised in order to prevent the vehicle from skidding, which is rather called as banking of road, right? So the difference in the amount of bending of road or any curve at various points is called as curvature. Now, let us analyze it graphically. Just consider a curve in an xy plane. In order to measure the curvature at any point, suppose at the point P, just observe here students, the extent of bending of curve at the point P is comparatively less to that of any point at the peak level. Now, to measure the curvature at P, we have to find out a circle of a best fit passing through the point P. And this circle is called as circle of curvature. The radius of this circle is called as radius of curvature, and the reciprocal of the radius of curvature is nothing but the curvature itself. So, to find the curvature at the point P, it is enough to find the radius of curvature at the point P and then take the reciprocal of it. The center of this circle is called as center of curvature. This circle has a very special property, that is, the curve and the circle have the same first and second order derivative at the point P. And larger the bending of the curve, smaller will be the circle. Since the extent of bending at this point is comparatively high, or I can say the curvature is more at this point. This results in a smaller circle of curvature. As a result, a smaller radius of curvature. Hope the points are clear to you. So, radius of curvature and curvature are reciprocal to each other. Now, let us analyze mathematically. Mathematically, the curvature is defined as the magnitude of rate of change of psi with respect to the arc length s. That is, at P, curvature is denoted as kappa and is defined as d psi by ds, where d psi is angle between the corresponding tangent at the point P and Q, and ds is the length of the element PQ. As I already told you, the radius of curvature and curvature are inversely proportional. So, radius of curvature is given by rho equal to 1 by kappa. It is equal to ds by d psi. To evaluate the radius of curvature in Cartesian form, we are going to use the formula rho equal to 1 plus y1 square power 3 by 2 divided by y2, where y1 equal to dy by dx and y2 equal to d square y by dx square. That is, y1 and y2 are the corresponding first and second order derivatives. Radius of curvature in parametric curve x equal to f of t, y equal to g of t is rho equal to x dash square plus y dash square power 3 by 2 divided by x dash y double dash minus y dash x double dash, where x dash equal to dx by dt, y dash equal to dy by dt, x double dash is d square x by dt square, and y double dash is d square y by dt square. Radius of curvature in polar form is rho equal to r square plus r1 square power 3 by 2 divided by r square plus 2r1 square minus rr2, where your r1 and r2 are the first and second order derivative of r with respect to theta. Just remember this formula, students. This radius of curvature in Cartesian, polar and parametric form, which we use to do in problems. Next is center of curvature. Center of curvature is denoted as x bar comma y bar and is defined as x bar equal to x minus y1 into 1 plus y1 square by y2, y bar equal to y plus 1 plus y1 square by y2. Once we know the center of curvature, we can find the circle of curvature using the formula x minus x bar square plus y minus y bar square equal to rho square, where rho is the radius of curvature. Here is the first problem, that is to find the radius of curvature for the curve. Its intrinsic equation is s equal to a log tan pi by 4 plus psi by 2. Just analyze this problem. Here s is given in terms of psi. So to find the radius of curvature, differentiate this with respect to psi. We get ds by d psi equal to, since log x equal to 1 by x, here we get 1 by tan pi by 4 plus psi by 2 into tan derivative is sec square pi by 4 plus psi by 2 into psi by 2 derivative with respect to psi is 1 by 2. Tan pi by 4 plus psi by 2, we can write it as sin pi by 4 plus psi by 2 by cos pi by 4 plus psi by 2. Cos you take in the numerator, so we'll get cos pi by 4 plus psi by 2 by sin pi by 4 plus psi by 2 into a by 2 into sec square pi by 4 plus psi by 2, you can write it as 1 by cos square pi by 4 plus psi by 2. This implies ds by d psi equal to, here you see cos pi by 4 plus psi by 2, cos square pi by 4 plus psi by 2, one cos you can cancel. So you will get a by 2 sin pi by 4 plus psi by 2 into cos pi by 4 plus psi by 2. We know that 2 sin a cos b is sin 2x. So this we can write it a by sin 2 pi by 4 plus psi by 2. Take 2 inside the bracket. So pi by 4 into 2 will give us pi by 2. 2 into psi by 2 psi. So this becomes a by sin pi by 2 plus psi. We know that sin pi by 2 plus psi is cos psi. So ds by d psi equal to a by cos psi. It is a sec psi. So radius of curvature rho equal to a sec psi. Coming to the next problem. Show that for the catenary y equal to a cos h x by a, the radius of curvature is equal to y square by a. Just analyze the curve here, students. Since the curve is in xy, that is in terms of the variable x and y, so it is a Cartesian curve. So to find the radius of curvature in Cartesian, the formula is 1 plus y1 square power 3 by 2 by y2. So here you have to find y1 and y2. So for y1, differentiate your curve with respect to x. So y1 dy by dx equal to a into cos hx by a derivative sin hx by a into x by a derivative 1 by a. So a and a cancel, you will get y1 equal to sin h x by a. For y2, you differentiate y1 again with respect to x. So we will get sin h x by a derivative is cos h x by a into 1 by a. Substitute y1 and y2 in row, we get a into 1 plus sin h square x by a power 3 by 2 divided by cos hx by a. So 1 plus sin h square x by a is cos h square x by a. So power 3 by 2 divided by cos hx by a. So we get rho equal to a into cos h square x by a. But from the given curve, cos hx by a, you can write it as y by a. So cos h square x by a will give you y square by a square. Substitute that in rho. Rho equal to a into y square by a square. So 1a will cancel. So we'll get rho equal to y square by 2a. Hence the result. So we get radius of curvature is equal to y square by a. So next problem, find the radius of curvature for the curve x square y equal to a into x square plus y square at minus 2a, comma 2a. So here given curve x square y equal to a into x square plus y square, and expecting you to find the radius of curvature at the point minus 2a comma 2a. So you have to find y1 and y2 at minus 2a comma 2a. That is first order derivative and second order derivative at minus 2a comma 2a. So differentiate this with respect to x. Since here left hand side is a product of two functions, for derivative you have to use product rule here. That is first function into derivative of second function plus second function into derivative of first function. Here I am going to consider x square as first function and y as second function. So x square into derivative of y with respect to x, that is y1, plus y into derivative of x square, that is 2x. So x square y1 plus 2xy equal to right hand side a into x square derivative with respect to x 2x. So 2ax plus y square derivative is 2y into y1 into a. So 2ay y1. Now here you can see that left hand side 1y1 and right hand side also y1 y1. So you need to send y1 together. So here what you will get, y1 into x square minus send 2ay this side. So 2ay equal to 2ax send 2xy to the other side, 2xy. So y1 equal to 2ax minus 2xy divided by x square minus 2ay. So at the point minus 2a, 2a, here you observe that denominator, if I substitute x equal to minus 2a, y equal to 2a, what you are getting is 4a square minus 4a square. That will give you 0. That is y1 becomes infinity. It is not possible. So you have to consider dx by dy instead of dy by dx for this problem. So differentiate your relation with respect to y now. So x square with respect to y means 2x into dx by dy plus y derivative is 1 into x square equal to a into x square with respect to y. So 2x into dx by dy, y square with respect to y, 2y. This implies dx by dy collect together. So we'll get dx by dy equal to x square minus 2ay divided by 2ax minus 2xy. So for x2, you differentiate this again with respect to y. But you see dx by dy is in the form of u by v. So you have to apply here quotient rule. So quotient rule means denominator square 2x minus 2xy square, then denominator into numerator derivative. Numerator derivative with respect to y is 2x into dx by dy minus 2a minus numerator into x square minus 2ay into denominator derivative 2a into dx by dy minus here again x into y, product of two function. So minus 2x y derivative is 1 minus 2y into x derivative is dx by dy. Now at minus 2a, 2a we have to find dx by dy. You will get equal to 0 and d square x by dy square. Since dx by dy equal to 0, substitute that and substitute x equal to minus 2a, y equal to 2a. You will get d square x by dy square is minus 1 by 2a. So radius of curvature at minus 2a, 2a is rho equal to 1 plus dx by dy square power 3 by 2 divided by d square x by dy square. So rho equal to, if you substitute dx by dy 0, then you will get 1 to the power 3 by 2, that is 1 by d square x by dy square minus 1 by 2a. So you will get rho is minus 2a. We know that radius of curvature is magnitude of this. So rho equal to 2a. Coming to the next problem, show that radius of curvature at any point t on the cycloid x equal to a into t plus sin t, y equal to a into 1 minus cos t is 4a cos t by 2. So here curve is in parametric form. So we know that radius of curvature formula in parametric is x dash square plus y dash square power 3 by 2 by x dash y double dash minus y dash x double dash. So you need to find x dash y dash x double dash y double dash. Given x equal to a into t plus sin t, y equal to a into 1 minus cos t. So derivative of x with respect to t is a into t derivative 1 plus sin t derivative cos t. Similarly, y dash is a into 1 derivative 0 minus cos t derivative sin t. Again, you differentiate this with respect to t, x double dash equal to minus a sin t, y double dash equal to a cos t. Therefore, radius of curvature is, in this substitute x dash y dash x double dash y double dash. So you'll get a square into 1 plus cos t square plus a square into sin square t power 3 by 2 divided by x dash a into 1 plus cos t into y double dash a cos t. So you'll get a square 1 plus cos t into cos t plus y dash x double dash a sin t into minus a sin t. So you will get a square sin square t minus minus will give you positive. So here what you will get, expand this. 1 plus cos t whole square is 1 plus 2 cos t plus cos square t. A square is outside, so each term a square will come. So you have to take out a square. So a square power 3 by 2 will give you a cube. Then 1 plus cos square t plus cos t plus sin square t. So will give you cos square t plus sin square t 1. 1 plus 1 2 plus 2 cos t power 3 by 2. So a cube into 2 power 3 by 2 plus 2 into 1 plus cos t power 3 by 2 divided by, similarly denominator also if you multiply and expand you will get 1 plus cos t, a square into 1 plus cos t. So a cube by a square will give you a, and 2 into 1 plus cos t power 3 by 2. 2 power 3 by 2, 2 root 2 a, 1 plus cos t power 3 by 2 divided by 1 plus cos t. So 3 by 2 minus 1. So you will get 1 by 2. So this becomes 2 root 2a into 1 plus cos t. I can write it as 2 cos square t by 2 power 1 by 2. So rho equal to 4a cos t by 2. Next problem is, find the radius of curvature at any point t on the curve x equal to a cos cube t, y equal to a sin cube t at t equal to pi by 4. Again it is a curve in parametric form, and you have to find the radius of curvature at the particular value of your parameter t. So x equal to, similarly you have to do x equal to a cos cube t, y equal to a sin cube t, x dash, y dash, x double dash, y double dash, and substituting rho. You can substitute t here only and find, or find radius of curvature in terms of t and substitute t equal to pi by 4. So if I substitute radius of curvature rho equal to 3a by 2. Next is, show that the radius of curvature at any point of the cardioid r equal to a into 1 minus cos theta varies as root r. This is, your curve is in polar form r in terms of theta. So what was the formula? Rho r square plus r1 square power 3 by 2 divided by r square plus 2r1 square minus r into r2. Here you need to find r1 and r2. That is derivative of r with respect to theta and theta. So r1 is what? Differentiate this with respect to theta, a into sine theta. R2 is r1 you differentiate with respect to theta again, a into cos theta. So here I am finding separately numerator and denominator. R square plus r1 square power 3 by 2. It is a square into 1 minus cos theta whole square plus a square sine square theta power 3 by 2. So it is nothing but a square you can take outside if you want. So you will get a cube into, you see 1 minus cos, similar earlier problem we done, 1 minus cos theta square, expansion is 1 minus 2 cos theta plus cos square theta plus sine square theta will come. So you will get 2 minus 2 cos theta power 3 by 2. So 2 power 3 by 2, 2 root 2. So a cube 2 root 2, 1 minus cos theta power 3 by 2. Divided by, here denominator r square plus 2r1 square minus rr2. If I substitute r, a square 1 minus cos theta square plus 2r1 square plus 2a square sine square theta minus r into r2. R is a into 1 minus cos theta, r2 is a cos theta. So a square 1 minus cos theta cos theta. Expand 1 minus cos theta square, this you multiply, you will get 3a square into 1 minus cos theta. Substitute in the formula, what you will get? You will get here a cube a square, 1a will come in the numerator, 2 root 2, 1 minus cos theta, 3 by 2 minus 1, 1 minus cos theta power half by 3. So you are getting here 2a root 2 by 3, r by a into 1 minus cos theta is r. R by a to the power 1 by 2. Since a into 1 minus cos theta is r, r by a is 1 minus cos theta, or a into 1 minus cos theta, directly you can substitute here r also. So here r power half, instead of r by, you can write directly r power half. So here a and half will cancel. If you are writing like this, here you can cancel out directly. You take a into 1 minus, oh no, here 1 minus cos theta power half is there. So 1 minus cos theta power half, you can substitute r by a power half. So a power half and a will cancel. So this becomes a constant into root r. So it is of the form constant into root r. That means rho proportional to root r. That is, rho varies as root r. So radius of curvature varies as root r for your cardioid r equal to a into 1 minus cos theta. Next problem is, find the coordinates of the center of curvature and circle of curvature at the point a by 4 of the curve root x plus root y equal to root a. So here for center of curvature and circle of curvature, we require x bar y bar. That is center of curvature, x bar y bar is, formula is given. So you need to find y1 and y2 for x bar and y bar. So differentiate your curve with respect to x. Similarly, we done so many problems. So similarly differentiate root x 1 by 2 root x plus root y derivative is 1 by 2 root y into dy by dx dy1 equal to, root a is a constant, so it is equal to 0. So from this y1 equal to minus root y by root x. Again you differentiate this for y2. y2 equal to, you apply the quotient rule, you will get this. You need to find here at the particular point a by 4, a by 4. So here only you can substitute and find. y1 is minus 1. y2 is, if you substitute x as a by 4 and y as a by 4, you will get y2 as 4 by a. So center of curvature is x bar y bar equal to x minus y1, 1 plus y1 square by y2, y plus 1 plus y1 square by y2. In this you substitute y1 as minus 1, y2 as 4 by a. So So x bar y bar, you will get it as 3a by 4 comma 3a by 4. That is your center of curvature. Now radius of curvature is 1 plus y1 square power 3 by 2 by y2. This implies 1 plus 1 power 3 by 2 by 4 by 8 is equal to 2 root a by 4. So rho equal to a by root 2. And circle of curvature at the given point a by 4 is x minus x bar square plus y minus y bar square equal to rho square. So that becomes x minus 3a by 4 square plus y minus 3a by 4 square equal to a square by 2. So this is your circle of curvature. Hope everyone understood this. Thank you, students.